Hi, my name is Sarah Junta, and I decided to focus on the effects of having children on parents' freedom for my statistics project. At the beginning of the project, I had been using 4 independent variables of sex, race, age, and the highest degree obtained, but for the purposes of the final, I decided to focus only on the independent variable of sex. The General Social Survey is where I got my variable, and it's a national resource survey that is composed of thousands of variables tracked since 1972 that range in topic to allow researchers to examine many aspects of society. The GSS variable Kidnofre was analyzed for my project. It was the dependent variable. It focuses on the opinions of parents on their level of freedom after having kids. The literal question was, do kids interfere with parents' freedom? The independent variable I focused on was the sex of the respondents. This variable is the direct response to the question, do kids interfere with parents' freedom? The total number of responders was 4,510. The frequency table shows that the parents involved in the survey disagree with the question/statement much more than they agree with it. My research question was, does having children affect the parents' freedom? The research hypothesis was the variable of sex has an effect on whether a parent believes their freedom has been lessened by having children. The null hypothesis used was the variable of sex has nothing to do with whether a parent believes their freedom has been lessened by having children. A histogram, according to our textbook, shows a frequency distribution. The values are plotted on the x-axis and the frequency of each value is plotted on the y-axis. The data contained in both a histogram and a frequency distribution table is the same, it's just shown differently. The histogram shows that more of the respondents were female than male. The total respondents was 4,510, with the frequency of male respondents at 1,228 and the frequency of females at 1,537. This correlation table shows the correlation between the variable of kids interfering with parents' freedom and the respondent's sex to be statistically insignificant with a sig value of 0.881 compared to the 0.05 significant level. This was the first hint that this variable may not have been the best one to choose for my analysis. But we press on. A cross-tabulation is a tool used to analyze categorical data. A cross-tabulation table shows the relationship of each possible combination of categories between two nominal variables. Both men and women answered that they disagree with the research question more than they agree. This is a cross-tabulation between the respondent's sex and the kids interfere with parents' freedom variable. Women answered that they disagree 21% of the time, 1,216 women total, and men answered that they disagree 16.1% of the time. So is a t-test appropriate? A t-test makes sense for analyzing individual variables, because the correlation is not very high between them. However, a t-test also requires all measured variables to have scores that are quantitative. In order to gain insight, I decided to run a t-test on the variables of sex and whether having children decreases parents' freedom. The research question was the same as stated before. The research hypothesis for this test was the gender of a person will influence their opinion about whether they have less freedom after having children. And the null hypothesis is there will be no correlation between men and women who believe they have less freedom after having children. The significance level for this test was set to 0.05 or 95%. Looking at the independent samples test table at the top of this slide, we see that the value under the SIG section of Leven's test for equality of variances is 0.822. Because this is well above the 0.05 level, we have no reason to doubt the equal population variances assumption. We read the top line labeled equal variances assumed. When we look at the value under the SIG two-tailed section, we see it is 0.881, which is over 0.05 significance. With this knowledge, we can't reject the null hypothesis. I ran an ANOVA test as well to see how the values vary between the t-test and an ANOVA. I used the same research hypothesis and null hypothesis as with the t-test. Once again, we failed to reject the null hypothesis with a sig value of 0.881, far above the level of 0.05. Even though it's not going so great, at least I have a conclusion. Based on the data received from both a t-test and a one-way ANOVA test, it is clear that we can't reject the null hypothesis of there will be no correlation between men and women who believe they have less freedom after having children. This suggests that mothers and fathers feel differently about their levels of freedom after having children. My references are the textbook Statistics for the Behavioral and Social Sciences and the General Social Survey. Hooray! Class done.